Welcome to Math with John, Natural Number Arithmetic, GCDs, and LCMs. Lowest common multiple, often called LCM. Multiples of a number are the results of that number being multiplied by a positive integer. Multiples of 6, for example, are 6, 12, 18, 24, 30, 36, and so on. Multiples of 4 are 4, 8, 12, etc. For any two numbers, x and y, x times y is a multiple of both x and y. So x times y is a common multiple of the pair of numbers x and y. In the case of 4 and 6, 4 times 6 is equal to 24. So 24 is a common multiple of 4 and 6. But 12 is a lower common multiple of 4 and 6, and in fact, it's the very lowest common multiple of 4 and 6. This makes 12 the lowest common multiple of the pair of numbers 4 and 6. Greatest common divisor, also called GCD. A divisor of a positive integer is a number that divides evenly into that number. The divisors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The divisors of 18 are 1, 2, 3, 6, 9, and 18. For both of these numbers, I just counted from 1 up to that number and wrote down the ones that evenly divided into it. Nothing fancy at all. The greatest common divisor of these numbers is 6. This is called the greatest common divisor. The greatest common divisor, GCD, of two numbers, like the least common multiple, LCM, are two tools that are used to help solve various other math problems. Factoring in LCMs and GCDs, oh my. Use factoring as a tool to find the LCM and GCD of two numbers. This method works for any pair of numbers that you can factor. The pair of numbers for the first example are 49 and 14. Start out by factoring both numbers. So 49 is equal to 7 squared, and 14 is equal to 2 to the 1 power times 7 to the 1 power. 1 will be written as an exponent whenever the value of the exponent is an integral part of a problem. For the greatest common divisor, GCD, we need the biggest number that divides into both 49 and 14. So for each prime number, take the lower exponents of the two factorization. This assures that this divides into both 49 and 14 at the same time. If a prime does not divide into both numbers, for example, 2 does not divide into 49 evenly, then exclude it entirely from the final GCD computation. So the details for the GCD of 49 are 2 is a divisor of 14, but not of 49. So it cannot be a part of the GCD for 49 and 14. 7 squared divides into 49, but not into 14. But 7 to the 1 power divides into both. 7 to the 1 is the only prime that divides into both numbers. So the GCD of 49 and 14 is 7 to the 1, which equals 7. The lowest common multiple has to include all of the divisors of both numbers. So for each prime, take the higher exponent rather than the lower one and include any prime that divides into either number. For 2, 2 to the 1 is the higher exponent, so include 2 to the 1. For 7, include 7 squared for the same reason. The LCM is a product of 2 to the 1 and 7 squared, which equals to 2 times 49, which equals 98. Sample problems. Find the GCD and LCM of the following pair of numbers, 7 and 9. No number greater than 1 divides evenly into both 7 and 9. So 7 and 9 are relatively prime. This means the GCD is 1 and that the LCM ends up being the product of the two numbers. In this case, this makes the LCM 7 times 9 is equal to 63. For 24 and 48, 48 is a direct multiple of 24. So after you do all the factoring, 24 is equal to 2 cubed times 3, and 48 is equal to double that. The GCD ends up being the smaller number, and the LCM ends up being the larger number. In this case, this makes the GCD 24 and the LCM 48. 90 and 12. For 90 and 12, 90 factors into 2 times 3 squared times 5. 12 factors into 2 squared times 3. The GCD uses the lower exponents, which is 2 to the 1 times 3 to the 1, which equals 6. The LCM uses the bigger exponents, 2 squared times 3 squared times 5, which equals to 180. As a partial check of our work, we can verify that 180 is a multiple of both 90 and 12, and that 6 divides evenly into both 90 and 12. These all check out. Thank you for watching this video. Please like and subscribe.